We're going to look at a slide of mesentery to see the appearance of loose connective tissue and some of the blood vessels classically associated with loose connective tissue. This particular slide we're looking at here, we don't have an equivalent of in your slide box collection. And the particular one that we're looking, which is from the NYU Virtual Microscope collection, has been stained with a stain that really just stains the components of the tissue blue, and it's very hard to differentiate individual components. I recommend that you look at the mesentery slide on the University of Iowa Virtual Microscope to get a better sense of what mesentery looks like. Mesentery is actually more like a sandwich with two layers of cells sandwiching some connective tissue, loose connective tissue in between. On this NYU slide we're looking at a whole mount of mesentery, which means that the tissue hasn't been sectioned, rather that the very thin sandwich-like mesentery has been squashed down onto the surface of the slide, and so we're in fact looking through the transparent cellular layers, which if you like form the bread of the sandwich, into the loose connective tissue meat. As we increase in magnification, there are various parts to this slide in which you'll see slightly different appearances to the mesentery. So here we have a large number of folds in the tissue where it's been squashed up, but also a fairly large number of blood vessels. And if we were to zoom in on the appearance here, in fact you'll see very nicely the meshwork of blood vessels here as an example that extend and ramify throughout the tissue. If you look on some of these larger blood vessels, which are just large capillary size, you can see nuclei of the endothelial cells that line these vessels, and are visible again here. What we can't see in this stain terribly well is the collagen fibers and elastic fibers of the connective tissue. This piece of mesentery contains a fair amount of fat, and we can see almost transparent here these cells which are unilocular adipocytes. The round nuclei, which are pale staining and have a fairly distinct nucleolus in the center, are the nuclei that belong to the cells that form the bread of the sandwich. So these are above and below the connective tissue as we look at it here. If we reduce in magnification again and move now to slightly different area in this mesentery slide, again there's blood vessels here, you can look at those in your own time. So if we move to this region out here where the preparation is actually at its thinnest, and increase in magnification, we can see some red blood cells which are scattered around, which have fallen out of capillaries. And then, although they're somewhat out of focus, you can see some purpley clusters of material like this. Maybe reduce in magnification a little bit. Some of which are fairly clear and can be seen in focus. And these are, this is a good example of one here, these are either macrophages or mast cells which you find migrating throughout the connective tissue. As I said, the stain that's used here doesn't allow us to see the connective tissue fibers, but they appear as almost a negative impression, which you can see here, some collagen fibers. So this is what the appearance of a macrophage looks like. Here's the nucleus of one of those cells, and again another nucleus of a cell that forms the bread layers, if you like, of this particular sandwich. And you can spend some time looking around again. If you go to the opposite side on this slide, perhaps again blood vessels. And if we go to this region here and again just zoom in, and you may find more macrophages and so on. If you had to guess at the identity of the cell types here, your best guess would be, if you were asked on any of these nuclei, would be a fibroblast, because fibroblasts make up the majority of the cell type that can be found in loose connective tissue. Loose connective tissue, as it's classically described, is really only seen in mesentery, a slide which you don't have in your box. Much more common is to find loose connective tissue, or a variant of loose connective tissue, underneath epithelium, and often closely associated with dense irregular connective tissue with which you can compare it. For the purposes of this short demonstration, we're going to use the penis slide, which can be found on the NYU Virtual Microscope slide. So to begin with, we'll increase in magnification somewhat, and we'll concentrate on looking just beneath the epithelium which covers the surface of the penis, which is skin, stratified squamous keratinized epithelium. And you can take this opportunity to revise the appearance of stratified squamous keratinized epithelium if you wish. Where we're going to look for loose connective tissue, as it's most commonly seen, is in the area directly beneath the epithelium itself. And a little deeper within the penis, and in a few minutes we'll look at dense irregular connective tissue for comparative purposes. So for now we'll concentrate on these finger-like projections of connective tissue which interdigitate with the downfoldings of the stratified squamous keratinized epidermis. Close to the top magnification now, and here we can see this is what loose connective tissue generally looks like when it's found beneath epithelium. You'll notice a couple of things about it. The first is, at top magnification, you can make out collagen fibers. This tissue hasn't been stained specially to demonstrate elastic material, although there are elastic fibers present. You can't see them. So the fibers which are found here are predominant, or visible here, are predominantly collagen type 1 and collagen type 3. The loose connective tissue is fairly cellular with lots of different cell nuclei. Most of these are going to be the nuclei of fibroblasts. Some of them will be the nuclei of other cell types included on the list which I've given you previously. And then finally, there are a fair number of blood vessels. There's an example of one here. Here's an example of one here. So open spaces where you can see squamous nuclei. Here's part of a blood vessel here. And so generally you can see that this tissue is relatively vascular. If we zoom out a little bit and move a little bit in toward the core of the center of the penis here, so looking in this region here, and if we zoom up at this point, now we're looking at dense irregular connective tissue. This is very dense irregular connective tissue. You can see great big plates of collagen with the nuclei of what are predominantly fibroblasts embedded in that material. And you'll notice that there are far fewer blood vessels and there are far fewer cell nuclei, indicating that this is a dense connective tissue, not as cellular as loose connective tissue. In the boundary between the two zones, so in areas such as this, you can zoom in and you'll see connective tissue that is in essence intermediate in its appearance between the denser connective tissue I've just shown you and the loose, very cellular connective tissue which is visible underneath the epidermis. So here again a classic example of dense or moderately dense irregular connective tissue, big plates or bundles of collagen fibers, predominantly collagen type 1, cell nuclei which are mainly those of fibroblasts. There are occasional blood vessels, as in here and here, associated with the tissue, but not as highly vascular or as highly cellular as, for example, here where we see blood vessel, blood vessel, blood vessel, blood vessel, blood vessel, and a lot of cells and cell nuclei found just beneath the epidermis. We're going to look at dense irregular connective tissue on a skin slide. Again, this is from the NYU Virtual Microscope collection. It will be similar but not identical to the skin slides which are in your box. And the substance of the skin is made up really of two major parts. The epidermis, which as we've seen before is a stratified squamous keratinized epithelium such as we see here. This is the keratinized layer. This is the vital or living layer of the epidermis. So from here to here is the epidermis, and then the bulk of the remaining thickness of the skin, so from here here all the way through to here, is called the dermis. And the dermis is made up principally of dense irregular connective tissue, and so this material we're looking at here is largely dense irregular connective tissue. We'll take a look at it in a little higher magnification now. And just as you will have been shown in the lecture, you can see collagen bundles. They are organized in different directions. Some of them appear longitudinally sectioned, some appear cross-sectioned. Interspersed among the bundles are cell nuclei. The majority of these cell nuclei will be from fibroblasts. If you look just beneath the epidermis itself, you'll notice that in a region immediately underneath it, that the area is considerably more cellular, and you don't have fibre bundles quite as large as you see in the dense irregular connective tissue. And there are a fairly large number of blood vessels. Here's a very good example of one here with the squamous endothelial cell. Here's a good example of one here with the squamous endothelial cells. And in this region where you have more cells and blood vessels and not the big arrangement of fibre bundles, this is what loose connective tissue found beneath the epidermis looks like. While you're on this slide, there are a couple of other things you could look at as well. In this slide, there's rather a large amount of adipose tissue, unilocular adipose tissue, which you can see here, and this is found in a layer just beneath the dermis proper called the hypodermis. Each of these cells which you see here had a giant fat droplet inside it, and the fat droplets have been washed out during the course of tissue preservation. What's left is a thin rim of cytoplasm belonging to the cell, and then perhaps it's cell nucleus here or cell nucleus here. So this is an opportunity for you to see adipose tissue. You can also revise epithelium again, particularly stratified epithelium such as is found in the ducts of some glands. So here's a duct. This one happens to have a simple cuboidal epithelium. This duct here with the narrower lumen has a stratified cuboidal epithelium, as does this one here. And you can look around on your slide and revise for your own purposes epithelium, so simple squamous in blood vessels, simple cuboidal and stratified cuboidal in the ducts of sweat glands, and then finally stratified squamous keratinized epithelium, such as you find which is the skin itself. Here again, here's a blood vessel, squamous endothelial cell, and then dense irregular connective tissue forming the bulk of the dermis, and then the appearance of this looser connective tissue with a more cellular appearance, which is found just beneath the lowest layer of the epidermis. We're going to look at a piece of tendon now. Again, this slide is from the NYU Virtual Microscope collection, but it's similar to the slides which you'll have in your slide box. Remember that by definition, tendon is dense, regular connective tissue, and there are two sections on this slide, much as there are on your own slide. One of the sections, which you see here, is of tendon taken in broadly a longitudinal section, and the other is of tendon taken in cross-section or a slightly oblique section. We'll start with the longitudinal section. We'll go up to about the middle of the magnification levels. And immediately here we can see that the background material is quite homogeneous. We go a little higher in magnification perhaps. And this is because of the very dense packing of the bundles or plates of collagenous connective tissue, which you see as pink. These are so tightly packed together that, going back in magnification a little bit, that the nuclei of the fibroblasts which secrete this connective tissue are trapped between the plates or sheets of collagenous connective tissue and are flattened somewhat, which gives this appearance of nuclei organized in parallel arrays or chains. And you can also see, as you move around, that some of the part of the tendon is in fact spirally arranged, which gives this kind of a zigzag appearance. And this is the classic appearance of tendon. You may also notice out on the surface of the tendon, on one side, or indeed on the opposite side, that there's some pink collagenous connective tissue which isn't as tightly packed as that in the tendon itself. And this is a bit of dense irregular connective tissue which forms a layer or sheathing on the surface of the tendon called the epitendinium. And then you can take a look, if you wish, at the tendon cut in cross or in oblique section, as we're looking at here. So we see again the very homogeneous, tightly packed bundles of collagen, the pink material here, and the cell nuclei, which are now cut in cross-section rather than longitudinal section, appearing as just very small dark dots interspersed around among the collagenous matrix of the tendon. And again, on slightly lower magnification, you'll see some dense irregular connective tissue forming that outer membrane on the tendon called the epitendinium.